So in this video, we'll be taking up the Chapter 1 review homework. So for the first question, very nice question. They just ask us for the degree and the leading coefficient. Not much to say there. For the second question, they ask us, they give us the graphs and they ask us if the degree is even or odd, and you can tell based on the end behavior. You can tell yourself whether the leading coefficient is positive or negative based on the end behavior. And then the domain and range, just approximate it if you can't see the scale very clearly. Identify symmetry if it does exist. So for the first one, there was no symmetry. For 2A, there was no symmetry. But for 2B, there was point symmetry about the origin. For question 3, they gave us 4 functions and asked us to fill in the table. So basically, looking at the degree of the function and the leading coefficient, you can determine what's the end behavior of the polynomial. Oh, in fact, they're all power functions. For question 4, they ask us to match up with the equation to the graph. So my strategy was just use the end behavior, because one of them was a quartic with a negative leading coefficient, and the other one was a quintic with a negative leading coefficient. So the end behaviors are totally different, and it's a dead giveaway to which graph is for which equation. For question 5, they're just asking for finite differences, so I just plug in the formula. For question 6, they give me the differences, the third difference, for example, or the sixth difference, and then they ask me to solve for the leading coefficient. So just rearrange a formula, and so it's the nth difference divided by n factorial to give me the leading coefficient. Okay, for question 7, I have a table, so I have to find the degree. Well, unfortunately, I had to do quite a bit of work. I had to solve for the fourth difference, and watch your work carefully. If you make a careless mistake, then it would cascade, and you'll have no idea what when the differences, finite differences, will be constant. So take your time, and if you solve for like the 7th difference and it's still not constant, you should really check your work. And since the fourth differences are not only constant but positive, that means the leading coefficient is also positive. Okay, let's do question 8. For question 8, we have the graph. We give them x-intercepts and the corresponding factors. They ask for least possible degree, so just look at the order of the zeros from the graph. Hopefully you can determine that. And the sign of the leading coefficient, which you can do using the end behavior. And they also ask us where the function is positive and where the function is negative. So just look at the graph and say, where is it above the x-axis and where is it below the x-axis? For question 9, they wanted me to sketch the polynomial function. So no problem, it's in factored form. But for 9b, I had to factor that difference of squares. But yeah, all the orders are 1, so it was pretty straightforward to graph that. For question 10, they gave me the zeros and they asked me to find the equation. So using the zeros, I can create the factors, and they all have an order of 1, so all the exponents were 1. Sub in the points and then solve for a. For 11a, they want to basically test whether it's even, odd, or neither. So the first one was odd, 11a was odd, and 11b was neither. So, oh, and 11c is even. Okay, so because it's odd, it has point symmetry at origin, and because it's even, it has line symmetry about the y-axis. And if it's neither, then it doesn't have any symmetry that I just mentioned. Okay, last 2. So for question 12, state the transformations, and then state the corresponding domain and range. Based on, for 12a, because you're transforming x to the 4, then using your translations, you can determine where the new absolute max or min point is located. So this one is an absolute because there's a reflection with respect to the x-axis, so it's opening down essentially. So it's an absolute maximum. Okay, and you went 1 right, 4 up. So the maximum, let me just write that down, is occurring at 1, 4 now. So I don't know the exact graph, but this is in my head. Okay, I have a transformed version of that quartic, that quartic power function in my head. So I have this, and that's how I know that's my range. For 12b, it's a lot easier because it was you're transforming an odd degree power function, which means domain and range is always all real numbers. In fact, you can say the domain and range for any odd degree polynomial will always be all real numbers. And lastly, they gave us a bunch of transformations and they asked us to write the equation. So that's really like a grade 11 idea. Just state the parameters once you know the transformations, and then you can generate the right equation.